Okay, so good afternoon, everyone, and welcome to our webinar, Just Ask xyzt.ai, Redefining Spatio-Temporal Analytics with GenAI. So I will immediately start with a demo on the xyzt platform, and the demo is all about this part of the A45, where used to be a bridge, and it's actually a very important bridge in Germany because it connected the north and the south, and it's on the A45 highway. So I will turn on the data. So now we see the data. We already drew two circles, one in the north of the A45 and one more towards the south of the A45. So I will use both as filter because actually what do we want to do? We want to analyze the traffic flowing or passing in the north and going to the south. So I will now put the filters here. So this filter here will be the from filter. So we will do from the north. And if I zoom out a bit, then here we will do to the south. So immediately we obviously see that the traffic is changing. And so if now I play with a bit with my timeline, then I see that the first week here, the traffic is normal. Most of the traffic goes over the A45 because the bridge is still there. If I now swap to the second week, then I see that the bridge was demolished and all the traffic is deviated from the north to the south. So it's pretty easy to do this type of analytics, but it can even be easier. So what if we could just ask our question and ask what we want to see? So imagine I go back to my example where I want to see the traffic leaving the A45 at exit 14 and then going towards exit 13. So my name is Nick. I'm the head of global business development at xyzt.ai. I brought today with me Bart Adams. Bart is founder and CTO of xyzt.ai, and he will tell us a lot more about GenAI today. So Bart, the floor is yours, and I think you will start with a demo.
Thank you, Nick, and thank you all for joining. So yes, my name is Bart, and I'm super excited today because I can talk about Just Ask xyzt.ai. We've been working hard on it, and as you will see, it's pretty amazing. So what I'll do is I'll go back to the xyzt.ai platform with the same example as Nick showed. And indeed, as Nick asked me, can you just ask the question? So in this case, I'm in my environment and I have those two similar shapes. You see them here. They're called exit 13 and exit 14. Since Nick was using north to south, I will also ask the same question. And I can now, as you can see here on the right in this little AI text box, I can ask the AI just show me all traffic from exit 13 to 14. And what it does now, it will basically compute the filter that Nick placed on his platform by just clicking around. It will do that by asking the GenAI model for the filter. And the result you see here in the little filter box, and let me make it slightly bigger so you can see what is going on. You can see that it's basically defining a route filter, and a route filter is to select parts of the trips of the vehicles that go through a certain stage of areas. So first, the car has to be in the exit area in the north, exit 13. Then it can be anywhere, and then it should be in the exit 14 area. And as Nick explained, because the bridge is not there anymore and the highway section is closed, it gives you a heat map on the map of where traffic is. But also on the timeline, you would see how much traffic there is over time that complies with this filter. And it's now super easy to just interact in a natural way, in natural language, and to immediately get to see what is there. The really nice thing with AI is that you can express yourself the way you like to express. For example, if I also want the traffic in the other direction, when I interact with someone, I would say vice versa. So I'll do the same with AI. It will interpret the query and it will update the filter for you. And as you can see, I'm not going to go through the whole syntax, but you can see there's a switch statement. And the switch statement is basically filtering on either of two directions. And as you can see, the first statement goes from 13 to 14 and the second from 14 to 13. So the AI is smart enough to basically interpret vice versa as the other direction. So that's what today is all about. And let me show you just by building up a few queries what the possibilities are. So Nick, what would you like me to ask?
Bart, I would love to see all the traffic from exit 13 to 14, but can we also ask the platform to do the same, but the other way around?
Yes, we can do that. And what I'll do is I'll do it differently. I'll do it so that we get the traffic that goes into the city center, because I just showed that exact query before. So I'll do a query now that selects the traffic that goes into the city center. And for smart city analysts, that's super important because you can imagine if a highway section is closed, what the impact can be on the neighboring villages and cities congestion-wise. So we have a lot of users on the platform that are using xyzt.ai for smart city analysis as well. So to show you all the possibilities, let me start from really the basics. So if you look at this data, and this is floating vehicle data from INRIX, which is basically a huge amount of GPS locations of cars with velocities associated, with vehicle types associated. And you see some of the properties here, like there's speed property, heading property, there's vehicle weight class, and so on. So the first thing you can do is you can just ask about one of those properties. So for example, you can ask only to see light traffic. And in that case, the AI is smart enough to understand that you're meaning to look at vehicle weight class and to filter on this particular value in that vehicle weight class. So I don't have to remember anymore what the exact name of this string was or the exact name of the property. So that's the first analysis I could do. Second analysis is I could extend that with, for example, a temporal filter. So I could say, because it's also temporal data, show me only that traffic at night. And as you can see, it updates the filter and it adds an additional, in the platform, it's called a record filter because it's filtering on the records on the time associated to each record. And you see it filters between 10 in the evening and midnight, between midnight and 6 in the morning. If you want to change that, you can just edit the filter and off you go. So these are just a few examples of what you can do, and you can do that on all the different properties. So you could, for example, do show me only slow traffic. And it will show you slow traffic. And in this case, it interpreted it as, okay, show the traffic that has a mean speed. So all the trips that have a mean speed below 30, that's what this filter says. It's actually not exactly what I wanted to ask. I really wanted to know, like, okay, what are the locations where traffic is stuck? So I could modify my filter to this. And as you can see, whoops, in this case, it did not do yet what I wanted. So I'll change it a little bit. So I'll ask, show me all locations where traffic is slow, because it was still selecting slow trips. And in this case, because I nudged it more to the speed property, which is associated to every single location, it creates a filter like that. And in this case, it interprets slow as 30, but maybe I want 5, and I can just say save it. And now I get to see, okay, during this time period, what are the areas with high density? And in this case, high density means the records with a speed property below 5 kilometers an hour. So all types of filters on the properties are possible, on the time is possible, and then on the areas or the traffic flow. And that's what Nick asked me to do, but I already did, so I'm going to do a different one. So I'm going to create a small area, and this is really for the smart city analysts. I'm going to create an area myself here, and I'm going to be a little bit lazy and just use a circle. And that area is going to cover that city, which is called Ludenscheid, and I call it just Ludenscheid City Center. And from now on, that area is available to the model to be used in any of the filters. So for example, what I can do now is I can ask, show me all traffic leaving from exit 13, driving through Ludenscheid. So like that. It's going to create me a filter. And in this case, it's going to create me a route filter, which sort of complies with all those conditions. And I'm going to walk you through. So basically, it says what the different steps have to be. First, the trip has to be inside that exit area, because that's what I'm asking for. Then it can be anywhere, and then it should be inside Ludenscheid city area. So this is a query that selects all the trips that have to be or pass through that area. And I get to see on the timeline how many trips there are over time. For a smart city analyst, what they're really interested in is not just seeing the trips that have to be there, but also the trips that go through that area, but that then continue. So I can extend my query. So I can say, okay, leaving from the exit 13, going through Ludenscheid, but then, for example, I can ask ending in Ludenscheid. It's going to adapt the query, and if all goes well, it's going to add an additional condition, and you see it here at the end. It says that the endpoint, and this is part of the language, that the endpoint has to be there, and it has to be inside that area. So if you now look at the timeline, and you look at the number of trips over time in those 2 weeks after the closure of the highway, and you compare that to the 2 weeks before, it's not so different. It's different, but still, if you look at the height of the graph, it's roughly the same number of trips. But on the other hand, if I would change my query and just say not ending in Ludenscheid, it should adapt my query so that this last statement, and you see it here, is basically negated. And you see that it's asking for the endpoint to be not inside the area of Ludenscheid. And you see the rest is the same. It's selecting the same flow of traffic, but there's an additional condition that the last point of the trip should not be inside this area. And if you now look at the timeline, you see that in those 2 weeks after the closure of the highway, there are many trips that are driving through that area, but not ending in the area. If you go back to the 2 weeks before, it is much less. So you see what the impact is of the closure of the highway. There's so much more traffic through the city center. And this is something that smart city people don't like at all. And typically then measures are taken to direct the flow of traffic outside of this rural area, but more onwards the remainder of the highway system. And our platform is exactly used for this. And now you can just get to those insights with a couple lines of text without having to know much about how to filter data. And that's really the power of this natural language interaction.
Okay, so Bart, thank you very much for this first demo and this first explanation. Seems pretty easy, but why are we using the natural language interaction?
Okay. Yeah, so I think I tried to convince you of it with the example, but really where I'll try to highlight where we come from. And about 5 years ago, when we started xyzt.ai, data science was really booming. And I think every organization that could afford was investing in data scientists and hiring data scientists. And you can do a lot of traffic studies or other analytics using data science. And basically, nowadays, that means that you have people that are skilled with writing Python code and that can look at data by extracting various statistics from the data. And so this arrow represents, for example, the time that you would need to do a traffic study and to deliver a traffic report, for example. Now, we as humans, we are very visual. And instead of working with code and looking at code, if you look at pictures like density maps and graphs and so on, we can much better understand what is going on. And allowing to do analytics with visualization is called visual analytics. And that's why we founded xyzt.ai. It's a visual platform to do analysis. We have many users that come from the data science world and were using Python or are still using Python, but in addition, they are using our platform and they report time savings to make a study of a factor up to 10. And the examples that were given was before we used to do 2 weeks of work to do a study. Now we can do it in a day or two. So that's sort of the time savings that we brought to the market with xyzt.ai. Now, with natural language interaction, we try to reduce the complexity of analyzing flows and spatial temporal data much more. And our goal is really to reduce the time by another factor 10. So instead of going from weeks to days, we hope that we can go to hours to do a study. And that's what Just Ask xyzt.ai is all about. So I already gave quite an extensive demo on traffic and mobility and smart city. What I'll do now is I'll switch to the platform again, and I'll go to a maritime example. So in this case, I'm not using floating vehicle data from cars and trucks. In this case, I'm using AIS data, which is basically GPS data from ships, from vessels. And on the map, you see a density map again. And in this case, it's about 3 weeks of data from Spire Maritime, who is a data provider in AIS data, of traffic through the North Sea. So if I zoom in on the North Sea area here close to Belgium, where we are located, you see it's quite a bit of data and there's quite a bit of activity in the data. So it gives you a lot of information that you can analyze. So let me walk you through some of the data properties. So of course, there's the speed property. Ships, they sail at a certain speed. There's a heading. There's some identification information like the name of the ship, the IMO. There's the flag of the ship and so on. There's a draft, how deep the ship is and so on in the water. So lots and lots of properties that are available to analysts. And the nice thing about this natural language interaction is that it is sort of sensitive to how language works. So, and a nice example I always like to give is the difference between, for example, vessels fishing, which the AI interprets as, okay, the status property should be equal to be engaged in fishing. And that's what we now see on the map. We see density of where there is fishing activity. So for example, for the intelligence community, that could be interesting to start analyzing illegal fishing. But of course, it could be other activity as well. But if I just swap the order of the words, I get a different meaning in the English language, but also the AI interprets it differently. It says, okay, now you're not looking for vessels that are fishing, but you are looking for vessels that are fishing vessels. So they are of the type fishing. And it's smart enough to do that, and it can sort of deduct that from the different properties in the data. And the nice thing is you can even do fishing vessels that are fishing, and the AI is smart enough to to combine the two before. And in this case, I'm looking at all the vessels that are fishing. Another example I would like to give is how the large language model can inject knowledge into what you're doing. So not just interpreting the language here, but also adding some additional information into the query. And a nice example is, for example, to ask, show me all large vessels moving slowly. And as you can see, if you would do this in SQL or in any more structured language, or in code even, there's insufficient information. Because we don't specify what large means, we don't specify what slow means. And in this case, the AI sort of injects knowledge that it has learned from other sources into the query. And it has chosen 200 meters as large and 5 knots as slow. And 200 meters for a vessel is quite large. If you know that container vessels, they go up to 300, 400 meters. But a vessel of 200 meters is quite large. And if you want to change it now to a different number, you can just edit the filter and it will do that it will update the map and the timeline and whatever you're looking at immediately. So this is a really nice example of how the AI is injecting knowledge into the filter. The final thing I want to do, and I'm going to switch to trajectories for that. So in the platform, we can visualize data not just by points, but we can also visualize data by connecting points together. And then you get trajectories of vessel movement. So in this case, what I'm going to do is I'm going to show another final example that does spatial-temporal analytics. So not just filtering on the data. For that, I want to show you that I have 3 areas. So the AI knows about those areas. I just drew them before the webinar. There's a Port of Antwerp, Port of Bruges, Port of Rotterdam. And I'm going to use them in my query. And it's actually an example that we also gave in the demo movie that we sent out a couple of weeks ago. So the first thing I'm going to ask is, show me all traffic from Antwerp. So very similar to before, it's going to understand that I want all the routes or all the journeys of the vessels that are first inside Antwerp, and then they can be anywhere. So you see how quick it is to do that filter. Port of Antwerp, a couple of years ago, they merged with Bruges. So as an analyst, I'm not only interested in Port of Antwerp, I'm also interested in the traffic that leaves Bruges. Notice how I can just type Antwerp and Bruges, and it's smart enough to sort of fill in Port of Bruges because it knows those shapes are there on the map. And then finally, a little bit of competition in the maritime domain. And I even made a typo here, I see, but it's again correcting for that. I'm asking from all those ships, give me only the ones that after a while get to Rotterdam. And that's what you now see on the map. Interestingly, we also see a lot of traffic going south here and then maybe back north and here. And that is normal because it can be that the ship leaves Antwerp, goes to the UK, and then goes to Rotterdam. So that's a valid journey of a ship for this filter. So what I'm going to do is I'm going to restrict my search area and add in some temporal constraints. For example, that take less than, let's take 5 days, which should be sufficient time to get to the Rotterdam area. And you see now what it did is it kept the spatial filter, which is the journey filter or the route filter, but it also added a duration filter. And duration is part of the syntax, and LT means less than. And this weird number that you see, 432,000, that should be the number of seconds in 5 days. So it made the deduction that the filter requires the number to be in seconds, and it made the deduction that it goes from 5 days to 432,000 seconds. And this is what you get out of it. And if you want a list of the vessels, you can get that from the platform just by clicking here, or you can just look at here and download the list of the vessels if you want. If I don't want to visualize this as a heat map, but instead I want to visualize this, for example, by the ID of the vessel, you get to see the full journeys of the individual vessels. And surprisingly, there's one vessel here that first goes all the way north, south, and then goes to Rotterdam. Or if you want to start replaying those journeys, you can start replaying those journeys. So you see how quick it is to combine this natural language interaction with visualization and visual analysis using just ask xyzt.ai.
Okay, Bart, thank you very much for the second demo. Pretty impressive. Now, can you tell us maybe a bit more how it works without obviously don't giving too much detail?
I'll give you all the details, Nick, don't worry. So yeah, how does it work? It's surprisingly simple in its concept. So first of all, there's the natural language query, which is basically what you're asking for, like show me all traffic from exit 13 to exit 14. That query is sent to a large language model, which is basically a trained machine learning model, but we fine-tuned it with examples, with tons of examples that cover the whole space of all possible queries that you could imagine. So that is there. And then as a result, it sends back a space-time filter in the syntax of the xyzt.ai platform. And that filtering by itself is quite unique on the market. It's a spatial-temporal filter. So you've seen the possibility to do the routing filters, for example. Now, this is not everything. There's a few small details. First of all, we also send information about the data. And this is basically, if you think about the data as a table, where every column in the table is a property, we send information about those columns. And I'll give you some examples on the next slide. We combine that also with information about the different areas, which I mentioned during the demo, so that the AI knows which different areas exist in the project. So a few words about those two things. The column information, it's basically just the names and the types of the columns. There's one exception. If the data type of a column is a text property, like for example, the flag of a ship, then we also send the most common values that we see in the data to the AI model. In that way, it can also reason about the values that different properties can take. So going back to the first demo with the floating car data, a column can be, for example, speed in kilometers an hour, and the type would be number. Second column could be vehicle type. It could be a text property, and the different text options are light, medium, heavy. In the example, it was a more complex string, but just for simplicity, I mention it like that. In the maritime domain, a column can be the MMSI, which is a number, the flag, a text, PA for Panama, and so on. Can be the draft, which is a number, and so on. And good to know, the XYZT platform is agnostic to the type of data. You can upload your own data with your own properties, your own columns, it doesn't matter. So if you have 20 columns or 10 or 5 and text and numbers, the platform can handle that. Then the areas, those are just the names. We only send the names. We don't send any geometry or any polygons. If you would have uploaded a shapefile or a GeoJSON file, for example, a world.shape file, which has all the countries in the world, we send the names of those countries to the AI model. If you have a drawing layer and you drew some shapes on the map, like areas, and you gave them the names, my area 1 and so on, we also add that to the picture. And that's basically what is there. There's one small detail that I want to mention, and that is that we validate the result of the large language model. We do sort of have, you can think of it as a compiler or a verifier or a validator that looks at the result, sees that it's correct syntax, sees that the correct areas and properties are used, that they exist. If not, we go back to the large language model, we tell it it's wrong, we also tell it as much as possible that we know what is wrong, and then we try again, and we do that a couple times, and then we get the resulting filter. So Nick, that's how it works, and I think I gave enough demo already. So that's it for me.
Thanks,
And I think
Bart.
I want to ask a question to you. How do you benefit from it, or how do our customers benefit from it?
Yes. So I think we can or we took 5 points that we want to take away from this webinar. So why should we go with GenAI? First of all, as you explained, save time. I think that our platform already was pretty quick without it, but it goes even 10 times faster with GenAI, so you can save even more time. Second topic that I can take away from this is that we can enhance the collaboration. So it's very easy to understand what your colleague did before you. If it's just written down in a sentence, then start digging into which filters he sets, which areas he chose. So it's a lot easier. Third, accelerate and broaden your skills. And here I'd like to always take the example of myself. Compared to Bart, I am not a technical person. And this way of working definitely gives me more capabilities and more possibilities in going even deeper into the data using the xyzt.ai platform as a non-technical person. Fourth one is you can interact, of course, in your own preferred language, which makes it easier again than digging into which filter should I use, which filter should I put, which area should I use. So you can just ask as if you would ask it to a normal person. And then the fifth one, we can incorporate real world knowledge. Meaning if I go back to, for example, Bart's example about maritime, the AI, for example, defines 200 meters as being a large vessel and defines 5 knots as being slow, which makes it even easier to use as well. So now we received quite some questions in our Q&A, but before the Q&A, we want to ask you a question. So we launched now, as we speak, our beta program. And so do you want to join? We'll give you a couple of seconds so you can answer. I think everybody should have answered by now. So let's go to the Q&A. Bart, most of the questions are for you, and there are some pretty interesting ones. So first question that I have here for you is, are we sending the actual data to OpenAI?
It's a dual question in a sense. First of all, yes, we are using OpenAI indeed. GPT-4, for example, is extremely powerful and extremely capable of doing this structured filter generation. What do we send actual data? The answer is no, except for what I explained. So except for your filter, the filter that you type, the names of the columns, the types of the columns, the names of the areas. And then for the text columns, we look at, I believe it's the 20 or 50 most common values in the data. So for example, if the column is ship type and there are 10 possibilities like cargo, tanker, fishing, then these possibilities are also sent. But actual locations, actual timestamps, actual records are not sent to the AI model. No.
Okay, thank you very much. Then we got a lot of questions about how adaptable it all is. So people asked, can I choose a specific vessel instead of a group? Can I look at a specific location? Can I just ask for the specific location instead of, for example, the whole region of Ludenscheid? So I assume the answer is yes, but can you maybe elaborate a bit more?
Yeah, so the answer is partly yes at this time. So what we focused on now to launch the beta program is really the filtering. Because that is what we see is the most powerful part of the platform and is also the most, I would say, complex if you want to master it and be able to apply all the filters. So we have the biggest gains there. But yes, it's adaptable. You can go quite far. You can just give the name of a vessel without any more text around it, and it will filter on the name and give you that vessel. So that's the yes. What is the no? But I think it's only temporarily. We haven't automated or wired together all possible actions on the platform. And for example, fitting them up on a certain area or fitting the timeline on a certain time period. We have not integrated that in the interaction. But that is something for the future, and that will be much more straightforward to do for us. But for now, the interaction with the platform for those cases is still rather easy and yeah, straightforward to do. But most likely at some point it will come. Yeah.
Okay, thank you very much. And then a last question, and I think it's a pretty interesting one as well. I assume it's because of the fact that we are using OpenAI. People asked if they can also run this in an on-premise environment.
Yeah, very good question. So I don't know if many people know, but the OpenAI large language model, like GPT-4 and so on, is just one of many. There are many open source models. There's many organizations that are training those models and making them available to us, to the community. So the answer is yes, you can run it on-prem, but it will not use the GPT-4 model. It will use a different model then. That model can be deployed on-prem as well. And the nice thing then is that you can have a deployment where, first of all, no data leaves the infrastructure of the deployment, but also your queries and so on, they will remain within that infrastructure, and you can run it air-gapped if you want. And air-gapped means for the intelligence people, that is like when your infrastructure is basically sealed from the internet and not accessible from the outside. So that it's definitely possible, yes.
Wow, okay. Thank you very much for answering or taking the time to answer the Q&A. For now, I think we're at the end of this webinar, so I would like to, first of all, thank everyone who joined us today. If you still have questions, remarks, thoughts, don't hesitate to reach out, of course. Again, if you want to join the beta program, don't hesitate to register. We will shortly also send you an email with a recording. And then for now, Bart, thank you very much again for a very interesting webinar. And to all of you, thanks for joining and have a nice rest of your day.
Thank you all. Bye-bye.